All right, we're going to do A and then B, so I'll make this a two-part video so it's not as long, so you'll see the first part, and then a second video will show you the second part. So in this one, we're going to do A. It says identify the type of curve given by each equation, then use symmetry, zeros, and maximum R values to graph the function. So this is R squared equals 16 sine 2 theta. So make sure to go back and look at those special types of polar graphs so that you can see where to specify. Where you see an R squared equals some other value squared and then sine 2 theta or cosine 2 theta, that will give you a lemniscus. Okay, so that is a very odd word, but this one is a lemniscus. And I will mispronounce that every single time, and that is fine if you do as well. So that one actually will kind of give you a infinity symbol type shape, depending on the stretch factors and everything. So we need to talk about the type of curve and the type of symmetry. Well, we did the type of curve. And then the symmetry, if you can see, it is that a sine graph. And so that is actually, but it is squared. So when you square it, it's actually going to give you an output that's going to be with respect to the pole. You can see in the two examples that if you look in the sine one, that will always give you symmetry with respect to the pole. So make sure to be looking back at that large concept summary piece of the special types of polar graphs. If the one in your notes is too small, it's on page 546 in your book. So now we need to go ahead and create our maximum R values. What we need to do is we need to focus on getting this into an R setup because that R squared does not help us out, obviously, because we can't graph it in that case. So in order to get R, we have to square root it. So we'd get plus or minus the square root of it, which would actually, don't need to do that. That would give us plus or minus 4 and then sine 2 theta, which sine 2 theta is undefined when it's smaller than 0, so it has to be a positive. So R is actually going to equal 4 the square root sine 2 theta. And we know that we are going to have to restrict it when sine is has to be positive, basically. So we are going to be focusing on the intervals from 0 to pi over 2, and then reintroduce it to the intervals at pi to 3 pi over 2. Okay, that's just going to help us out because that's where the domain is going to be restricted. There will be nothing that exists. Now, if you do it from 0 to pi over 2, that will actually give you all the values, and then we will mirror everything because that is quadrant 1 and quadrant 3. So those are mirrored with respect to the pole. If you try to do anything in quadrant 2 or quadrant 4, if, say, you don't pay attention, that will give you undefined answers. So you want to make sure that you focus between 0 and pi over 2 for your tables. Rather than having to go back and create a table for the sine and cosine curves in that rectangular format, we can look at this and see, because we are focusing from 0 to pi over 2, that is going to give us a maximum when our A value is 4, because that is, by definition, our amplitude. So whenever we get it to be 4 or negative 4, that's going to give us a positive and a negative answer. So going ahead and filling out the table, yes, this is different and may take some time. If you need more videos, I can provide them. I can try to find some on Khan Academy or on YouTube. But really, these are a little bit more strategy-based. And I clearly cannot talk and write at the same time. pi over 3, 5 pi over 12, and then pi over 2. So we really only need to focus on these, on the interval from 0 to pi over 2, because everything will, in fact, be mirrored to the other side because we've got that plus or minus. So going ahead, plugging these into your calculator, I'm going to give you the decimal version. So you'll get 2.8, which means you'll get plus and minus 2.8 because that will give you the mirrored direction. Then you'll get 3.7, which will be plus or minus 3.7. Pi over 4 will give you 4. That is our maximum. Then we get 3.7 again, plus or minus. Then we get plus or minus 2.8. If you look at that symmetry, we're seeing things are very symmetrical. And then 0. That is all we have to do for this piece. So we see our zeros are at 0 and pi over 2. And then our maximum's at that 4 and negative 4, so that will take us in the other direction. Everything is going to have that positive and negative form because we've got that square root, that plus or minus that we're going to be kind of taking a peek at. So go ahead, graph these points, play the video in a second, and then I will show you what my shape looks like so you can check it. And then that will be the end of this video, and in the next video, we will focus on part B. Okay, and here is your shape. This one obviously uses up all 4 poles that I have in mind. Your guys' is different, so you'll want to scale it. But that's what you look like, where you've got an infinity sign mirrored at that pi over 4 marking. That's basically going to tell you that it's mirrored at the pole because of the way that we have the symmetry placed off of, logically, what is symmetrical off of this. And so that's what we have for this piece.